we're going to look at the sum and difference of cubes. So this is our sum of cubes, and then this one is our difference of cubes. So if we look and see what we can find for patterns, so notice we have a cubed here, but then this is just a. This is b cubed, this is just b, right? So what we did is we took the cube root of both of those, or it's just both of these are perfect cubes, so then you take that number, or letter or variable. Okay? And then what I like to do for the second part is I like to look from this set of parentheses to this set of parentheses. So from here to here, we squared it. From here to here, we squared it. And then I have these two things being multiplied, but notice the sign went from positive to being negative. So if we look at this one, we have a cubed and it went to a. We have b cubed and it went to b. So these two patterns are the same. Both of these were a cubed, they went to a. Both of these are b cubed, they went to b. Now notice this had a plus here, so this one has a plus here. This one has a minus here, so this one has a minus here. Okay. Now, if we follow, this one we squared, this one we also squared, so that pattern holds. This one we squared, this one we also squared, because even if you take it with negative b squared is still positive b squared. And then this, we took this and multiplied it and then changed the sign. If we take this and multiply, we get negative ab, but notice we would change the sign here for that. So our sum and difference of cubes have a very similar pattern for what it is. Now, you must be very careful. Over here, I wrote what we have used before. So this is squaring a binomial. And that, notice this is very similar to this. These two things are similar, right? Or these four things, I suppose I should say. Right? This one has 2ab. This one only has ab. So the way that I help myself remember this is that when you have a squared, that's when you have the 2ab. When you have a squared, that's when you have the 2ab. This is cubes, so it's not a squared. It's also not a cube. So just realize that that is what our pattern is. So now what you want to do is you want to be able to factor. So if I give you an example, if I give you 125 minus x cubed. Now you may or may not be very familiar with your cubes. So what you want to think is 125 a perfect cube? Well, you can do this a couple of ways. In your calculator, you can take the cube root of 125 and see if it is a whole number. Remember, your cube root is under math, and then it looks like this. Or you could do 125 raised to the 1/3 power, which is the same thing as the cube root of 125. Those are both ways that you could use your calculator to get there. So if we do the cube root of 125, we do indeed get 5. And if we take the cube root of x cubed, that's really just x times x times x. And remember that we need a group of 3 to get out, so then that just turns into x. Okay? So remember, our pattern is that this was a cubed, and I get a. This was b cubed, so I get b. So that means the cube root of 125 is 5. So this is 5. And then the cube root of x cubed is just x. And then remember that whatever sign is here is the sign that goes here. So those match. So this will be a minus. Then, to get my second set of parentheses, we square both of these. So square the first and square the last. So if I square this one, that's going to be 25. If I square this one, that's going to be positive x squared. And then remember, we're not dealing with squareds. These are cubes, so it's not 2ab. It will be just ab. So I'm going to multiply and change the sign, and that goes there. So this is negative 5x, so I changed negative 5x to positive 5x. Now, another way that you could do this is you could use this acronym of SOAP to help you remember the signs. So SOAP stands for the same, then opposite, not odd, sorry. Opposite, And then this last one is always positive. Okay. So notice if we look back up here, these two are the same. These ones are opposite. This one's always positive. These are the same. These are opposite. This one is always positive. So you can use the SOAP to help you remember that you have this is the same, these are opposites, and then this one is always positive. So if we try another example, if I give you x cubed minus 27. Okay. So if we try x cubed minus 27, x cubed is a perfect cube. If we look at the cube root of 27, 27, that's 3. So this is a difference of cubes. So I do x and 3. This is the same. Then I square this one, which is x squared. I square this one, which is positive 9. And then remember that these two are opposites, so this will be a plus, or you can think of multiply and then the opposite. That goes here, so negative 3x, and I change the sign to positive 3x, and then this whole thing is my answer. Now, if you were to multiply this out, and you did x minus 3 times x squared plus 3x plus 9, you would end up simplifying to x cubed minus 27. So we can just do that real quick. So this is x cubed plus 3x squared plus 9x minus 3x squared minus 9x, and then minus 27. So notice these are like terms, and they go to 0. These are like terms, and they also go to 0. So then you would just end up with x cubed minus 27. Okay. So remember when you're factoring that you're really undoing multiplying. Okay. Now, let's take a look at this one. So if we take a look at this one, we're going to look at 125. So if we look at 125, the cube root of 125. Again, if you don't remember how to get to it on your calculator, you go to math, and then it's the fourth one down, and then it's 120, and then hit enter on that, and then hit 125, and that tells you that the cube root is 5. Now on this one, we have both a variable and a number. So I have to think, well, the cube root of 8 is 2 times 2 times 2, so 2. And then the cube root of u cubed is just u. Okay. So I take the cube root of 125, which is 5. The cube root of 8 is 2. The cube root of u cubed is u. This is the same. If you want, you can do this is the same, this one is opposite, this one is always positive. And then you've got your spots that you need for your number. Okay, so to go from here to here, we square it. So 5 times 5 is 25. To go, this looks like a 24, so let me fix that so it looks more like a 2u. Slightly better, I suppose. So if I square 2u, I'm squaring both the 2 and the u, so that gives us 4u squared. Then I'm multiplying these ones. I already put the opposite sign, so this gives us 10u, so it's minus 10u. And then this whole thing is the answer. Okay. Let's try another example. If I give you negative 2x cubed minus 54. Okay, well, I look at this and 2 is not a perfect cube, and if we put in the cube root of 54, it gives us a decimal. Well, what are we doing wrong? Well, notice there's a common factor. You should always be checking for a common factor first. Okay, so you can take out the common factor. Now, you have a choice here. You could take out a 2 or you could take out a negative 2. Personally, I would take out a negative 2. So if we take out a negative 2, that leaves us with x cubed plus, and then when we cut 54 in half, that leaves us with, excuse 27. So now the negative 2 will just remain on the out in front. So I'm going to take the cube root of x cubed, which is x, the cube root of 27, which is 3. This is the same. And I do odd, and then always positive. So I square this one, it's x squared. I square this one, which is 9. And then I multiply and change the sign. We've already changed the sign, so this is 3x. So it's negative 3x. And then this whole thing is our answer. Okay. Now, we could have, just so you can see for argument's sake, if you had chosen to just take out the 2, you would get a negative x cubed and then minus the 27. So it goes from a sum of cubes that we had on the last one to this is a difference of cubes. Now, you do have to remember this thing about cube roots. When I take the cube root, it's okay if you have a negative underneath the root. So let's take negative 27. If we break down 27, that's 9 and 3. If we break down 9, that's 3 and 3. Well, if you remember about your negatives, I can do negative times negative times negative, and all 3 multiplied together will give me negative 27. So then this is a group that can be taken out for, sorry, I forgot to put the cube root, for the cube root of negative 27. So having a negative under a cube root is totally fine. A negative under a square root or any even root causes you to have imaginary numbers. So then here, if I take the cube root of negative x cubed, that'll just be negative x times negative x times negative x, which gives us negative x. And then the cube root of negative 27, like we just showed up there, is negative 3. So that gives me negative x, excuse me, minus 3. Okay. Then, remember that sign is the same as this one, so these are both minuses. Then to get our second set of parentheses, I'm going to square this first one. When I square a negative x, that becomes a positive x squared. When I square this one, it becomes a positive 9. And then remember, I multiply and change the sign. So this is positive 3x when I multiply. I change the sign, so it's minus 3x. Oh, sorry, it's a positive 3x when you multiply two of them together. So it gives you, oh yeah, so negative. So this one is different because of this is negative as well, so that changes our pattern slightly, so the SOAP doesn't work on this one. This is another reason I like to take the negative out in front. Notice that if I were to distribute this negative 2 through here, then I would get negative 2x minus 6, and if I distribute the 2 here, I would get negative 2x minus 6 as well. So they're equivalent. And then this part matches exactly, so they're equivalent.